Hi, everyone. Welcome to this webinar where we're going to look into a case study of the construction of a net zero home. Today, I'm going to be presenting. My name's Emmanuel Cosgrove from the Ecohome Network. And with me, I have Salvatore Ciarlo. Hi there.
Hey, good morning to all and welcome to this session. So looking forward to chatting with all of you today. My name is Sal Ciarlo. I'm the Technical Services and Codes and Standards Director with Owens Corning Canada. So Emmanuel and I will walk you through this exciting project and this case study. So enjoy, and turning it back to Emmanuel.
Thanks. Yeah, on my end, I'm the director at Ecohome, and I was a builder, and I still have a hand in exciting demonstration projects like this one every once in a while. So we'll be able to, get to the real goods and talk about pricing and feasibility and especially about sustainability and reducing the carbon that families in suburban areas generate annually. So we're going to talk about the studies we did. We actually did market studies. We're going to get into more technical information about how everything works with and Sal's going to introduce everything that was done as far as the envelope goes. We're going to then move into section 4, which will be more mechanical aspects. And then we'll talk cash. How much will all this cost? And is it really a viable business model for builders? And then we'll get into just the photo gallery, show you what the final result was, because we've been at this project for a few years now, and it just got finished. So at the end, we'll be able to answer questions. And that's basically our outline. So getting into sustainable homes, what are they all about? For those who are new to the field, we'll look into what they are. Just to briefly introduce Ecohome, we're a BC-based company, and we help Canadians and North Americans basically get. We inform them about choices they can make at home as far as affordable, low carbon, sustainable homes. We do training for consumers as well as business industry professionals. So how did this project come about? We did a market study with 1,001 Canadians, and we found out that 1 in 2 don't really know much about green homes. The good news is 1 in 2 do know about green homes, and when we ask questions about people's interest in buying new homes, a full third of the people responded that they're going to be on the market for a new home within the next 5 years. So we know that the market for new homes is very heated in Canada right now, and it's often in suburban areas. And for eco folks like us, it's a little disconcerting to know that people will be pretty car dependent with their choice of their lifestyle, where they're going to live with regards to where they work and so on. If we look at Canadian households, we know that carbon emissions and energy. The majority of those emissions will be related to where we live, where we're located. Transportation is the lion's share of our carbon emissions as families. Heating, on the other hand, will be 29% of our energy consumption. Hot water, only 6.5%, and all other plug loads like lighting and appliances and everything else that uses energy at home will be 29%. So plug and heating are pretty much half and half, and hot water is another share. But like I say, once you involve vehicles, we get a better idea of where greenhouse gas emissions are coming from. In our market study, 62% wanted to buy a single family home. Only 1 in 5 was interested in buying a condominium. So we know that Canadians are still attached to the single family home model. So what are sustainable homes all about? Basically, they're better built homes that are more future-proof, that go beyond national building code. They often involve the use of non-toxic materials, so better indoor air quality. The sustainable homes usually have better detailing as far as waterproofing, and have more insulation than code. There's often heat recovery systems, whether it be air exchangers or drain water heat recovery, and of course, very energy efficient appliances. So that, in a nutshell, is what sustainable homes are all about. They'll also have the low maintenance, low watering landscaping, for example. There are a lot of standards out there. In provinces like Quebec, there's Nouveau Climat that get funding for builders, but elsewhere in Canada, there's Built Green, there's LEED certified, as well as Passive House that's gaining ground. People are getting interested in the rating systems coming from Europe. And then there's net zero energy. What is net zero energy? Well, we'll get into that in just a second. What it all boils down to is greener homes are simply better. They're studies have shown that it's a more solid financial investment, and it's for people with values surrounding sustainability. It's just an obvious choice. The certification programs out there are helping make consumers make better decisions with third-party certification. So all in all, healthier. I mean, it's just not a good idea to not build sustainably in 2020. So let's get into our pilot study. That's based on the construction of a net zero home. Net zero is a certification program that was launched by the CHBA in 2017, and it creates a guideline for builders to build up to being net zero ready, as we would say, and then we'll provide the guidance as well for those who want to go all the way and integrate photovoltaic energy generation, solar panels, into their building mix. The study we did that we're presenting today went all the way. So in our market study, we found that half of people surveyed found that the whole idea around net zero, even though they don't exactly know what it means, they find it very attractive. So that's also good news. And it's especially good news for the climate, which is our the goal of all these projects put together. So how do we get to net zero? Well, we got to build really efficiently. So we got to drop energy consumption by about 2/3 of a standard code-built home. 2/3, that's not like 5%, 10%. That's 66%. That's pretty aggressive as far as an energy target goes. Of course, it depends where your provincial code is, where your baseline is. But for standard codes across Canada, getting to the point where the square footage available on a roof can generate enough energy with PV panels to be able to get to the net zero energy bill annually is requires a lot of work, and that's what we're going to get into to show you how we got to that point in Mascouche, Quebec, and where we demonstrated that if you charge an electric vehicle, an EV, you're actually combining a net zero ready home with an electric vehicle, and you're actually saving $1,500 annually. So when you compare those two consumer choices, the house and the car, you're actually ahead of the game, $1,500, even in today's prices. If you look at a code-built home, in our case, this was in Quebec, we modeled, our team of engineers did all the energy modeling around the different scenarios, and if we took the same plan and built that home to code, it would be consuming 28,000, just about 29,000 kilowatt hours annually. In Quebec, where energy is pretty cheap, like it is in BC and Manitoba, because it's hydro dams, basically, that's about $2,500 annually. Now, if we get to net zero ready, we drop those 29,000 to 11,000. We can see it's almost your 2/3 drop, and the energy cost goes from 2,500 to 800. And you're going to ask, well, that all sounds great, but how much does it cost to get to that energy efficiency? Don't worry, we'll get into it. Then we go to the net zero home, where we basically take a net zero ready home and add PV to it. You see the solar panels on the roof there, with net zero, you drop your energy costs to a beautiful zero annually. That's what can make consumers really react positively. It's like, hey guys, you want to pay nothing for energy annually? Well, come check out this option. So the good news for the climate is that yeah, we think we're sitting on something that can really drop carbon emissions of Canadians dramatically. We're not talking twice as much carbon savings. We're talking 12 times less greenhouse gas by combining a net zero ready home with an electric vehicle. 12 times less carbon emissions from a family living in that scenario than a family living in the exact same house with an equivalent car, just that uses gas to propel itself. So we're it's pretty astonishing that once at the end of the day, when we did all the calculations, we take into account the carbon emissions from the grid mix. We're not trying to cheat here. Electricity does have carbon emissions, obviously, but in this case, with our case study, we're pretty impressed with 12 times less carbon emissions per family. So yeah, we think that the whole our climate crisis can be remediated even in the worst of areas like peripheral areas around Canada's big cities. So let's talk technical, Sal. It's all yours.
Thank you, Manuel. Great job in getting us to this point, and I think you set the context and the goal clear really well. So what I want to talk about next is basically how it works, and I'm going to talk about the building envelope first, because the building envelope lasts for the life of the building. So it is one of the most cost-effective. It's one of the most cost-effective way to get to net zero ready. It's very efficient. And if we do it right the first time and it's optimized, you've basically got a building. It's going to last. It's going to last for the life of the building, and you've got a building that you can, or a home that you can offer your customers that is future-proof. So we know codes are going to change. We are on the road towards net zero ready, mandatory net zero ready performance by 2030. We know codes are going to require better performance of the building envelope over the next 10 years in cycles to allow the industry to prepare. And so what we're saying is, hey, why build a house that is going to be under par when the codes change in 3 to 5 years? We have the opportunity to do it right now so that we don't have to retrofit these buildings later on. And and we will show you it's very cost effective to do it. It's beneficial for the environment, and it offers better quality and durability for your customers. So basically, it's important to optimize the envelope. Like I said, it starts with the envelope. Once the envelope is optimized, that's where we can add on the other components, so the mechanical components, the window components, and then you're basically minimizing your energy demand so that you can put in a cost-effective renewable system that'll generate whatever you need to maintain your occupant lifestyle. So an optimized building envelope, the first and foremost, like Emmanuel said, it's all about energy savings. There's a huge potential for positive cash flow by optimizing the building envelope. So Emmanuel shared some of those numbers, and we'll see them in the next slide. But also occupant comfort. So beyond energy efficiency and savings, a good envelope is a comfortable envelope. I mean, constant temperatures, no drafts, no cold surfaces, less noisy. If the electricity goes out or utility goes out, you can operate for a significant amount of time. Sustainability. I mean, we see climate change, and so a better built envelope is going to be a more durable envelope, a more durable home, and so it becomes sustainable. I mean, resiliency. Again, where we no more power outages, we like to say. So if there is a power outage, you're basically self-sufficient for a long period of time. That's important because we know that those will happen. There's a high probability that they will happen. We want to make sure we're able to be get beyond that. Improved indoor air quality. Emmanuel touched upon that. So away from pollutants from the outside, radon gas. A better built envelope doesn't allow air to come in or out, doesn't allow water to come in, doesn't allow gases to come in. So it provides for the ultimate living environment. And again, if you optimize the building envelope today, you're basically ahead of the curve in terms of code changes. Codes will change as we get towards net zero ready by 2030. We know we're going to have to upgrade. And if we know what the recipe is now, why not build it today so that we don't have to go back and retrofit our buildings? So just on the energy side, so like Emmanuel mentioned, you look at the heating energy required for a code-built home versus a net zero ready home. It's a significant drop for both heating and air conditioning. When you look at the total energy used for a code-built home versus a net zero ready home, I mean it's a no-brainer. You're basically saving lots of energy, or actually bringing it down to zero, and for a very limited amount of cost on a monthly basis in terms of cash flow. So what did the building envelope look like in this house and at the Crema project? So if we look at the different components, slab on grade, we basically insulated the underside of the slab with an R10 extruded polystyrene insulation. So the benefit of that is not only reduced heat flow or energy loss, but also occupant comfort. So you can walk barefoot on that slab and you're going to feel comfortable. You're not going to have that radiant loss from the body to the cold slab. Foundation walls, we went up to R25. So if we look at what code requirement is today, it's about an R17. So we kind of increased it because there is a lot of heat loss that goes through basements. So it's a good opportunity to reduce energy consumption or heat loss in the basement. And what we use is, again, extruded polystyrene, 5 inches of it, because it actually provides a good thermal barrier, moisture barrier, air barrier, and water vapor, as well as a radon gas barrier. For above ground walls, current code is R24.5. We brought it up to R effective 34. So basically 2x6 studs, smart framing, not 16 inches on center, but 24 inches on center. So less wood, less thermal bridges, less cost. And we can build 24 inches on center with no issues. We eliminated the thermal bridges by putting R10 on the exterior. And we optimized the insulation in the cavity space, the 2x6 cavity space, with an R24 batt. So we are currently today, we're putting in R20 batts. R22 and 24 batts are on the market. They've been available for the longest time. And it's just replacing one product with another product that has a higher R value, and you're done. You basically don't have to touch that wall moving forward. In the attic, just more loose fill insulation. And I'll show you the pictures. We actually also cut the thermal bridges by putting an R5 continuous insulation on the underside of the ceiling, which eliminated the thermal bridges, but also allowed us to make that lid airtight, as opposed to trying to seal it with poly, which is very difficult to do when you have a lot of penetration, such as spotlights. You'll see what we did there. And then the garage, the room above garage, we went to R40. Again, always a combination of fiberglass insulation in the cavity and continuous insulation on the exterior. In our case, we used extruded polystyrene. And then the air tightness, and we brought it down to less than 1.5 air changes per hour. There is opportunity for improvement. We can get as low as 0.6, 0.7, but the target is less than 1.5, and we should be aiming towards an air change of 1. That's how it's an opportunity to reduce energy consumption, but also improve durability, minimize risk of moist air moving through that wall and potentially causing issues. So if we start with the basement, So here's what we did at the Trema project. We basically put a combination of extruded polystyrene on the inside of the foundation wall and on the outside. So the benefit of insulating the basement on the outside is that you're basically keeping that concrete dry. You're keeping it warm. And so the durability just increases by a huge magnitude. So if ever there's a crack on that wall, and we all know foundation walls will crack, but if it's protected on the outside with a hydrophobic material, there's no hydrostatic pressure, there's no moisture infiltration. That concrete actually acts like a heat sink as well. It's just a great detail. So insulating basements from the exterior is a huge opportunity to improve overall energy efficiency performance and minimize unintended consequences, minimize moisture infiltration. And what we also used here is an innovative product at the top of the foundation wall. It's a foam glass insulation that is manufactured by Owens Corning. It's called Parasol. And basically it's an insulated block that you put underneath the first row of masonry. It can support 2 stories of masonry, and it basically eliminates that thermal bridge at the top of the wall. So you have that nice continuity from the wall to the top of the foundation wall to the exterior insulation all the way down to the footing. No thermal bridges, great detail. This is what we did at the Trema project in terms of foundation walls. And when it comes to the slab, so what we use is extruded polystyrene under the slab. We tape the joints. And so basically the product gives you several levels of performance. It gives you an air barrier. It gives you a moisture barrier because it's hydrophobic, a vapor barrier. So you don't need poly because it has a vapor barrier capabilities. It also it makes it comfortable, but also a radon barrier. And so now you've basically provided a great indoor air quality, good moisture management system, and you made the lower living space very livable and comfortable for people to use. Now, keep in mind, a lot of folks are working from home, and a lot of times we have our home office in the basement. We want to make sure that we optimize that living space, make it as comfortable as possible. And these are some of the ways that we can do that. Consider insulating the basements on the outside. Finish with some insulation on the inside, and then insulate the underside of the slab. Make it all airtight, moisture tight. You've got a great lower living area. And when it comes to the above grade walls, so what we did basically is first thing is you optimize the stud spacing. So smart framing, don't use a lot of studs at corners. Try to minimize the amount of wood that's used because that's a thermal bridge. And so if you can do that, you just by moving to 24-inch centers, you can basically show a reduction in energy efficiency by a significant amount. That's a simple step to reduce energy demand that is doable, that we can do it today, and it works. And so what we did is smart framing, 2x6 studs, 24 inches on center. We optimized the cavity, so we went with an R24 batt at 6 inches thick. So that is currently available in the marketplace, an easy substitution for an R20 batt. Take one, replace it with the other, you're done with respect to the cavity. And then on the exterior, we use our innovative CodeBord air barrier system using our extruded polystyrene with taped joints and a series of compressible gaskets to basically help us get to the air tightness level of 1.5 and less from the exterior. So once we did that, we no longer need to seal poly on the inside, no longer need to worry about all those crazy complicated details around headers. You're basically putting in fiberglass insulation, you're putting an unsealed polyethylene vapor barrier or replacing it with a vapor barrier paint over top of your drywall. So now you can completely eliminate the poly. You're using the drywall and the paint as your vapor barrier because you're completely airtight on the exterior. It's easier to achieve the continuity. There's lot less details to treat. And keep in mind, if you're airtight, you're also watertight. So if you're airtight on the exterior down to the levels of 1 air change per hour, confirmed by a blower door test, the chances of water getting into your wall are very minimal. If you're airtight on the inside, so we can get the similar levels of performance by sealing poly and working all those complicated details, it doesn't mean that you're watertight on the outside. So that's the beauty of moving the air barrier plane to the outside. Durability, performance, comfort. When it comes to the walls, like I mentioned, easy opportunity to really optimize the building envelope. We should really consider putting in R24 batts. We have one time to do this as opposed to going back, opening up the walls and fixing it. So at time of construction, it's the right time to put in the maximum R value that's available in terms of a batt insulation in that space, which is an R24 batt. So I encourage that you consider doing that. And then for the ceiling, so what we did here is we just increased the level of insulation with loose fill insulation. So we went to an R60. The current code in Quebec is R40, 41. And we also put in R5 extruded polystyrene on the underside of the trusses, the attic trusses. So what that does is it actually reduces the amount of insulation required to get to R60 effective, because you're basically eliminating the thermal bridges. So that means a lower heel height, which translates into more savings from a cladding perspective. If I have less cladding to put on the outside because I have a lower heel height, it translates to significant cost savings. But also on the inside, it's easy to make that lid, the upper level, airtight. You're putting in a piece of foam, you're taping the joints. If you're cutting pot lights into that, it's easy to seal around that. Any vents, venting that goes through it, very easy to seal around that. When you're putting poly, very difficult to seal those areas. And by experience, when we've done blower door tests in buildings where they don't get to 1.5 air changes per hour, most of the time the leakage is occurring at the lid. So at the upper level, because of those penetrations, there's no continuity. The poly is not properly sealed continuously along the top plate, and or at the headers. Now, if your air barrier is on the outside, your header is sealed, no more issues there. And if you put in an effective air seal using a rigid foam board on the ceiling, not only you're also airtight at that level. So it's a clean, efficient detail that has several benefits, like I just mentioned. And then also in terms of shingles, I mean, hey, climate change. I mean, the climate is changing. More violent storms, more wind, more rain, more snow. And keep in mind, we are putting solar panels on these buildings, and so just putting shingles with no underlayment doesn't make a lot of sense. I mean, what we want to do is make sure we've got proper underlayment protecting that wood throughout the entire area of the roof, and then put in a durable shingle. And once currently we have our duration shingles, which are very, very durable, so that once you install your solar panels, there is no issues, and you don't have to access or remove your solar panels to go fix a blowout or a roof leak. You want to make sure that it's there for a long, long time. So again, the opportunity to do it right the first time, underlayment throughout the entire area, and put on a good shingle, because we know we're going to put on solar panels, and we want that whole system to last for the life cycle of those components, which is about 25 years. So you want to do it right the first time. And with that, Emmanuel, I'll turn it back to you.
Thanks, Sal. All I'd add as far as the envelope goes is that this project is undergoing LEED certification. So it's a pretty low score, considering that the blower door test was done under compartmentalization. Compartmentalization are the new protocols in rating systems like LEED and Energy Star, because for twin homes like this house, there is a party wall, and there can be air leakage through that party wall. So this project, being a semi-detached, would have done much better as far as the blower door result. had we depressurized both units at once. So yeah, it's a modest 1.23 air exchanges at 50 pascals per hour. So anyways, onto the PV system. There are different ways to configure energy generation through photovoltaic panels. There's always a net zero configuration where you don't have a battery backup. If you want to be fully grid independent, that's a whole other issue, because you need batteries, which are an extra cost, and also you can, well, I guess you can do a hybrid of the two, where you are grid intertied, like you would do with a net zero home, but you'd also have a battery backup. The whole idea, which is interesting for utilities, is that when you have battery backup, you can participate in peak shaving programs and energy management programs if they're available with your local utility. Ideally, we could do vehicle to grid or vehicle to home. When you combine an EV, an electrical vehicle, which has a battery, so it's a wonderful thing. You've already bought a huge battery, usually lithium based, when you buy an electric car. So it enables us to open the road to being able to sell electricity back to the electrical grid at certain times of the day, and what we call V2G, vehicle to grid, as well as when there's a power outage in the home, instead of relying on a battery setup that you have installed in the home, to just transfer loads to your car battery while it's plugged in. Now, there are a few manufacturers of vehicles that allow the vehicle to home or vehicle to grid configuration, like Mitsubishi with their Outlander EV, or the Nissan Leaf. So here's basically the calculations of Ecosolaris, who did the installation and the sizing of the setup at the Tréma demonstration home. So what we could fit on the roof of the townhome was 22 panels from Canadian Solar that are each have 315 watts each. There was a vertical rack installed, and the anchors were installed previous to finishing the shingles, and we're talking about an output of 6,930 watts, with an annual estimated production of 8,000 kilowatt hours. So in our definition of a net zero home, we're talking about what panels can produce on site. In an urban context like this, we're not going to cover the front lawn full of solar panels, so our south-facing roof basically dictates what our energy budget will be. If you're really building towards net zero, you gotta pretty much go back to your roof design, and that's why these homes that initially had 4 slopes got brought down to 2 slopes. So we had to go through permitting again in order to allow for the net zero design, because forest slopes really take away a lot of square footage and a lot of potential energy generation on your roof. So building to net zero has a lot of considerations, even down to house designs. So the PV systems without battery backups are a lot more affordable, because you don't have to invest and reinvest in new batteries every, like lead acid, every 5 years, for example. And it's definitely not as expensive as lithium batteries. So ideally, use your car as a battery and sell that to you as a concept to your clients. Vehicle to home, vehicle to grid is really where the future is. As far as lifespan, solar panels will last. They're all, every year we're realizing that the first solar panels built in over 50 years ago are still ticking. So lifespans are pretty much unlimited as far as we know, but the panels are usually guaranteed 25 years. And so there's a lot of benefits to just going with grid intertied net zero homes. Yes, the whole idea, if you want to be resilient during power outages, is to definitely see if there is a vehicle to home options available with your or vehicle to grid options available with your local utility. So here's the installation on the roof of our demo house by Ecosolaris, where you see the racks down below. It was a straightforward install. We know that the PV industry across Canada is really ready for the masses now. It's not like it's something that's never been done before. So now that we've seen how to build and what the net zero involves, let's get into the nitty-gritty of the price. Back to our market study, 85% of the people surveyed say they're willing to pay more if they get lower energy bills and improved comfort. But usually, once it comes time to writing the check, people aren't so willing. It's easy to answer survey questions. So our lesson here is that we really have to get our sales teams on board with high performance homes, because if you can't sell them, people won't buy them. It's that simple. You need to be very convincing. And what we realized in our pilot study is that there were 35 of these for sale. And the good news is they went like hotcakes because the price was right. And the sales team were all very informed about how significant, how special these homes were. So people are willing, but you gotta convince them. Here's a table that breaks down the net zero project versus an equivalent home just built to code. there are a lot of funding schemes across Canada, such as discounts on mortgage insurance, like Genworth or the CMHC. It's actually 10% of the what you'd pay in mortgage insurance over the span of the mortgage. So that can add up. It's all there are certain banks like Desjardins in Quebec that offer incentives up to $2,000 per home. There are incentives as far as insurance policies that offer discounts for green homes. So once you add everything up and you look at the extra cost for buying an EV, yes, for example, an Outlander plug-in hybrid or a Nissan Leaf versus Nissan Sentra, for example, will cost around $11,000 more. But once you get your federal rebate and you get your provincial rebate if it is applicable, usually the cost to operate an electric vehicle will be much lower. You'll be saving on a monthly basis. So when we combine, in this case, a home that is net zero ready, built to a LEED Gold standard. I mean, you're talking a seriously good house with an electric vehicle. The two together, once you subtract all the rebates that are out there that are available for homeowners, you're actually saving almost $1,700 annually. And of course, 12 times less greenhouse gas emissions from the family that lives in that home. So yeah, it's what energy to power the house, heat the house, and energy, which is electricity to gas your car, is about the price of I'd say a large coffee at Tim Hortons. So on a daily basis. So it's just a pretty simple thing to sell to your consumers, because it becomes a real joke as far as energy costs. Sal, if you want to let us know about the
Thanks,
price.
Emmanuel. I think you made a great point. So on this slide, we can see that in this project, the incremental cost to get the net zero ready. So that's basically optimizing the envelope, getting better air tightness, more insulation, better windows, better mechanicals, hot water recovery pipes. It cost around, the incremental cost versus was about $20,000, $21,000, and then to get to when we added the photovoltaic, then you add another 24. But if you just look at the net zero ready home, so the incremental cost was 21,000. We were able to basically optimize, future-proof the home. You don't go back. You don't need to touch it. You don't have to reopen walls. If you're that homeowner, eventually, as codes change, your house doesn't depreciate in terms of value when other homes in the future are going to be built to a better level of performance legislated by codes. You're basically future-proof. And if you looked at what Emmanuel showed the previous slide, if you take into account all of the subsidies that are out there for your homeowners, basically, and you bring it back to a monthly cash flow cost, building the house of today the house of tomorrow today, sorry, actually costs you less, from a cash flow perspective. So it really makes a lot of sense to do it right now, to optimize it all the way, especially given the fact that it's going to cost less from an operational, from a cash flow perspective, when you tap into all the subsidies. And you're providing your homeowner with a better built home, a more comfortable home, a safer home, and higher resale value, future proofing. All of the advantages are there. It really makes a lot of sense to build the house of tomorrow today, given the fact that it's not going to cost more from a cash on a monthly from a cash flow perspective. Emmanuel, did you want to continue?
Yeah, thanks. Yeah, just to that point, why build stupid homes when you can build smart homes that are cheaper than stupid homes? I mean, the choice is clear. And we see builders, once they get a taste for this type of construction, there's no going back to building stupid homes. I mean, it would be an insult to code officials to say that code is stupid, but from a financial perspective, code just isn't enough. It's a much smarter and much more cost efficient to build well beyond code. And yeah, for this project, $350,000 is for a 1,600 square foot home is yeah, what we could consider very affordable. Sorry for those in Ontario and to the west of Ontario. I know these are prices that haven't been seen for a while in some areas, but that's what this project went for. $350,000. So resale, when you've got a house that's built better than the code in 10 years, and you can show low energy bills with a great history, you're doing pretty good. So as far as this home went, well, this is what it looks like last week, where yeah, we see landscaping is in with permeable driveway with a rain garden even off to the side. Like we said, we are undergoing LEED, we're aiming for LEED Gold certification here, which makes us think about other things other than yeah, just envelopes. It is a demonstration home, so here we see the cutout in the slab where we can see how the slab was built with a plexiglass. There was also a cutout with plexiglass to show the drain water heat recovery. We see the air exchanger here, as well as a hot water tank with a heat pump from Rheem, which is yeah, creates hot water by transferring heat from the air. So when the house can't respond to the demand for hot water, it the heat pumps, the split heat pumps, which are quite affordable, will kick in extra heat that the hot water tank, the hot water heat pump, will eventually compress into hot water. So you're talking cutting the price of hot water to about a third of what it would cost if you were using electricity. And at that price, across Canada, you're a whole lot cheaper than gas. That said, a net zero home with gas, in our opinion, doesn't really make sense, because unless you're quite special and you do produce natural gas at home, it's hard to reach net zero, which is truly a zero energy bill, not a low electricity bill with another gas bill. So this home was all electric, with no gas. Here we see the EV charger from EV Duty, as well as the controller for the photovoltaic system on the roof. And for an affordable home, the finishes were really well done. And the people who actually bought the home we met last week, and they're thrilled with especially the comfort. Whether it's hot out or cold out, you can't really tell in these homes a lot because of the not feeling the radiation off the glass, not feeling cold from the walls, even in the foam glass perinsole. That was, for me, that was one of the most beautiful things on this project, to cut the thermal bridge for a comfortable basement, because often when you've got masonry cladding, those bricks are transferring a lot of cold directly into the foundation, which basically makes exterior insulation useless. So in this case, the basement was insulated from both sides, and the thermal bridge was broken from the masonry with the foam glass block. It can be purchased as of now, as far as I know. Yes, it's a 3-bedroom home, and it's net zero for an affordable price. So to wrap up, we definitely like to thank Natural Resources Canada for their generous support in allowing us to communicate and to do a lot of building science behind this demonstration project. We'd like to also thank Groupe Tréma, who is the developer that trusted us in getting involved in this whole adventure. And the great news is Groupe Tréma now offer net zero ready or net zero across all their 5 projects that where they build at least 200 homes per year. Yeah, they had a great experience, and are making net zero ready their new standard across the board. There's also Ecosolaris and EV Duty that we'd like to thank for their participation in the project, and of course, above all, Owens Corning for being a leading manufacturer of pretty much thermal solutions to buildings, because we're not just talking about selling insulation anymore. It's a full system that involves air tightness as well, and durability. So thanks for watching. Sal, you want to have the last word there?
Yeah, thank you, Emmanuel. And so Emmanuel was very humble there, but Emmanuel and his team, Ecohabitation, Ecohome, have done a tremendous job in this project. And I want to congratulate them and thank them for their passion to help move the industry forward, but also the entire team, obviously Natural Resources Canada, for giving us this opportunity. And especially Groupe Tréma, Jean-Sébastien and Philippe Marchand, and their team. They've committed to being the best they can be for helping move the industry forward. They're committed to their customers' success, or their customers. They want their customers to have the best product possible. And so making this step forward, showing through this pilot project that it is possible to build the house of tomorrow today in a sustainable, affordable way, and in a community setting, not just one house that for people to look at, but houses for people to live in, houses for people to feel the comfort, the durability, the resiliency. And so that took a tremendous commitment, a tremendous effort, but that integrated approach, that commitment, that desire to be the best and to offer the best product in the marketplace is outstanding, and it needs to be recognized. And so I wanted to thank Group Tema for giving us the opportunity to help them along their path towards net zero already. And as we saw today, it is possible to do it today, to do it now. We need to build beyond code right now. It does not make sense to go back and retrofit these homes, especially new homes, when we have the knowledge, the opportunity, and the technology and the know-how to do it right the first time right now. So again, thank you for your attention. Thank you for the time spent with us today. And please feel free to reach out to any one of us, including Emmanuel and his team. They're there, and we're there to support you in this path towards net zero already, which is real and which can be done in a very efficient way. So thank you once again. Thank you, Emmanuel.
Thank you.